Solving special systems. I have the system y equals 5 minus x and y equals 2x minus 7. We've already went over how to solve systems by graphing, solving by substitution, and by elimination methods. Which method would probably be the most efficient? Substitution. I want you to solve the system. I have y equals 5 minus x, y equals 2x minus 7. Substitution method. Both of these are equal to y. So all I'm going to do is put 5 minus x is equal to 2x minus 7. Move my like terms to the same side. So I'm going to add x over here. And put the 7 to the other side. 5 plus 7 is 12. 2x and 1x is 3x. Divide by 3. X is 4. Regardless if you would have tried using a substitution method or elimination method, you still should have an answer of x equals 4. I take this one and put it into one of the two equations. I like the top equation better. There's less things to substitute in for. I don't have to multiply anything. Y equals 5 minus 4. Y is equal to 1. Which means my final solution is 4, 1. This here is called a consistent system. A system that has one or many solutions is called consistent. There's one unique solution that lies where the lines intersect. This is called consistent independent. If I were to take both of these graphs, or both of these equations, y equals 5 minus x and 2x minus 7. There's the first one. There's the second one. And they intersect at 4, 1. This is called a consistent independent system. The big thing about today is going to be solving a problem as usual and then labeling what type of system it is. There's a couple different types. Solve this problem. Which method is probably the most efficient? Elimination. Which variable do you want to eliminate? X or the y? Well, we need to pick one. Okay, the y. What do I have to multiply to get the y's the same? -3. I have to multiply everything in the top equation by -3. The bottom one I can keep the same. -3x, -3y equals -3 times 3 is -9. Bottom one stays the same. 3x plus 3y equals 9. Gone, gone. So I'm left with 0 over here. Not -9, -9, 0. I have 0 equals 0. Everything canceled out. Now, if you might have used the substitution method, you probably would end up with like 9 equals 9. Since 0 equals 0 or 9 equals 9, that means there are infinitely many solutions. And that means the lines are really the same. This is called a consistent dependent solution. What was the first one called? Consistent and independent. What does it mean to be independent? You're on your own, which means you only have one answer. You're on yourself. This one, it's 0 equals 0. Is 0 equal to 0? Is 9 equal to 9? That's why it's consistent dependent. If I go into the calculator, now I have to rearrange these in order to put them in. So move the x over, becomes negative x plus 3. If I move the 3x over, and then I have to divide everything by 3. Y equals, I'll just do this. In parentheses, negative 3x plus 9. And I have to divide it all by 3. And I'm going to make this line here darker. When I press graph, there's the first one. I don't see the second one. If I go, and I'm going to go over to the left, I can change it from a line. I'll do this one, which puts a 0 along it. See how it's graphing? It's the same exact line. The two lines are on top of one another because it's the same exact thing. Questions on the differences? Try this one. I have 2x minus y equals negative 1, 4x minus 2y equals 4. Which method is probably the most efficient, the quickest? Elimination. Which variable is probably quickest? X or the y? The y. What's the common number for my y's? 2. So I have to multiply everything, this one by 2. Are the signs the same or different? Same, so I have to make this one a negative. When I distribute through, negative 4x plus 2y equals 2. 4x minus 2y equals 4. All right, gone, gone, so that's 0. Equals 2 plus 4 is 6. I have 0 equals 6. Does 0 equal 6? No, it's not true. Since it's not a typo, I'll explain that in a minute. Since 0 equals 6, then this system is called inconsistent. The two lines are parallel to one another. They never intersect. If I look and graph them. All right, I got to move the 2x over and change the sign of everything. So negative 2x becomes positive 2x, the negative 1 becomes positive 1. I have to move the 4x over, so I'll do it the same way I did the last time. Negative 4x plus 4, and divide everything by negative 2. There's the first one. There's the second one. They're parallel to one another. How can I tell that two things are parallel to one another? They have the same slope. When I rearrange both of these, the slope is the same. Both of the slopes are a half. Now, I know I have 0 equals 2 here. Is that the only way I could have solved this problem? No. I could have eliminated for the x. If I eliminate for the x, I might get 0 equals 5. Is that true? No. Just going through and showing you what happens if I solve for the x. If I solve for the x, what's the common number? 4. So I have to multiply everything here by -2. I still get the same thing. Some people might do substitution and rearrange. If you do substitution, you might get a different number. Just because you got 0 equals 2 and the person next to you got 0 equals 6 doesn't mean one's right, one's wrong. You both technically have the same answer, but it's what your work matches with. Let's try this one. I want you to solve this problem. Determine if it's consistent independent, consistent dependent, or is it inconsistent? Which method might be easier? Okay, elimination you can try. What do I have to do for elimination? It has to be rearranged. If I rearrange this, it has to be lined up in order. For this one, substitution might be a little bit quicker. There's two ways I can use substitution. But for both of them, which variable is probably the best one? The y. If I use the top one, what do I have to do to solve for y? Subtract the 4x over. If I solve for y here, what do I have to do? Now, if I divide everything here by 2, I have y equals -4x minus 4. With the substitution method, I take this and I substitute in for the y here. I like this one because I don't have to multiply anything. I just take it and replace. When I replace this, 4x plus -4x minus 4 equals 6. All I did was put it in brackets so you understood that was y. What's 4x minus 4x? 0. I'm left with -4 equals 6. Does -4 equal 6? This means it is no solution, which means it is inconsistent. I could go further and add over the 4 and have 0 equals 10. Is 0 equal to 10? No. Once the variables have disappeared, now you have to decide, is it consistent or is it, is it consistent dependent or is it no solution inconsistent? When it's not true, it's inconsistent. Let's try this one. Which method is probably the best? Substitution's probably the best. And there's a reason why I have it written like this. This right here becomes this right here. I'm going to substitute in 5x equals 1 minus 5x plus 1. Now what do I need to do? Can't combine like terms yet. I have to distribute. 5x equals 1. This negative, you have to be careful about because it goes to the 5x and the 1. So it's -5x minus 1. Now I can combine my like terms. What are my like terms? Well, I have to combine the 1 and the -1. What's 1 and -1? 0. I have to move this 5x. How do I move this 5x? Add 5x, add 5x. What's 5x and 5x? 10x. Equals, what was left over here? What do I do now to solve? Divide by 10. What's 0 divided by 10? X is 0. I actually get an answer here. Coming around, I saw a lot of you had 5x equals negative 5x and wrote consistent dependent. Is 5x equal to negative 5x? Are they the same exact thing? No. They have to be completely identical. Just because there's a 5 and a 5 doesn't mean it's the same. Now I take this and substitute in. Which one of the two is easier to substitute in for? Top one or the bottom one? Top. Put in 0 here. Y equals 5 times 0 plus 1. 5 times 0 is 0 plus 1 is 1. Y equals 1. My answer is 0, 1, which means it is what? Consistent, bless you, independent. Consistent, independent. This is a problem where people get tricked up on because they forget to distribute that negative. Or you see the 5x and the negative 5x and you think they're the same. Now I just want to go through and show you if we were to solve this by elimination. If I do this by elimination, I need to get things lined up. And usually when I line them up, I want x's, y's equals number. This is out of place, negative 5x. The y is fine, equals 1. The y is out of place. So I'll put it over here, y. The 1 is fine. Which variable is easiest to eliminate? The x's. Because if you look, they're already the same and they're opposite signs. What's 1y and 1y? 2y. 1 and 1 is 2. Divide by 2, divide by 2. Y is 1. I'm going to substitute in here. 1 minus 1 is 0. Divide by 5, divide by 5. X is 0. 0, 1, still same answer. Questions on this lesson?